What are all the genes necessary for making a human brain? All the genes necessary for making a human liver or the heart or any part of the human body. And now the fun stuff begins because we get to start to crack that code having the order of the letters in front of us. But fundamentally, it is very much a digital code.
The secret of life itself, the DNA molecule. A genetic discovery that could give man the ability to create life to specifications. With it comes the power to change evolution itself. Never have we had such opportunity or such awesome responsibility.
Change DNA structure in the lab is fairly straightforward and it's fairly simple. You can study a piece of DNA to unravel its function. You modify the composition and you see what the effect is on function. That's daily routine in a lab that has this technology. Going from the lab to the person to therapy, in theory, is the same thing and is as simple. In practice, it has been shown that it's a lot more difficult. And the reason why it's so difficult is not that we don't know what pieces of DNA to put in, is that we do not succeed sufficiently and at a high rate in getting these pieces of DNA in the right cells. But we have learned how to do it from nature. What is a viral infection? It's a virus that sticks to the cells, that enters the cells, and that uses the machinery of the cells to multiply itself. Now you take this virus, you cut out the pieces that are dangerous so that it will still stick and be engulfed but not develop in the cell. And then you add to this some other tools that the virus then can use to cut out the bad DNA, stick in, splice in the good DNA. This is a mechanism that is used now to do gene therapy using viruses.
The ability to tamper with our genes has obvious applications. We can change DNA to prevent or cure hereditary diseases. We can alter the DNA of donor organs that are to be used for transplants so that the body of the recipient won't reject them. The organ doesn't even need to come from a human being. It could perfectly well be that of an animal.
Pigs would be a good supply of kidneys or other organs to transplant in humans. But because of the difference between the two species, the pig kidney or the pig liver will be rejected by the human. So if we can humanize the pig kidney by putting in some human DNA, which will make the cells look a little bit more human, so that they are not rejected by the person immediately, then there's a better chance that you'll have a take. And this is tried to humanize animal tissues, and it's becoming a big industry because we need more organs.
I think increasingly we're going to start realizing that this body is not sacred. The way we are is not some kind of God-given plan. It's really a pure random accident. We take two sets of genes and we shuffle them and something comes out. Sometimes it's a wonderful product, sometimes it has a hole in the heart, sometimes it has psychosis or tendencies towards extreme anger, has addictive problems, can't concentrate, all kinds of defects. To say, oh, that's normal, that's sacred, that's good, to me is rather absurd. It's random. There's not a plan there that we're thwarting. So genetic engineering seems to me one of the most moral things we can do.
A single species is defined by the isolation of our genetics, reproductive isolation. But when you begin to take genes from different species to mix together all of the genetics that is available among all animals, and also to design new alterations to the genetics, well, reproductive isolation really doesn't have much meaning anymore. And so you can imagine all sorts of forms and that will evolve in the future.
In the future, we will be able to sculpt our bodies like living sculpture. Our bodies could be beautiful electronic designs that shimmer prismatically in the light, in the morning light. It could change forms. It could become a piece of marble on one hand and then totally mutate into some fluid type of luminescent, snake-like quality. After all, the body is an extension of fashion.
You can rearrange the human body and try to make humans fly, even though humans are very heavy. And some mammals fly, like bats fly, but they're much lighter. But it's an intriguing question because it brings up the issue of not just trying to take an injured human and returning them to normal, but taking a human and making them superhuman, making them go beyond.
Our future is not to try and hold back genetic engineering, but to try and use it in a way that best serves us. If our children can be more intelligent and healthier and live longer lives through altering our genetics, why would we not want to do it? I mean, imagine if other children could live for 2 centuries, and if you could only live for 80 years because your parents believed that it was improper to tamper with human genetics. You would not be pleased with that decision. The same thing if your IQ were a normal IQ and all of your classmates were much, much brighter because there had been sort of some biological or genetic manipulation that was possible. You'd feel very angry about this.
Once we know exactly how our DNA code functions, we will be able to enhance our bodies. Human life will improve from one generation to the next as we control and accelerate natural evolution. But a rival to mankind is appearing on the horizon, a rival that is evolving much faster.
Are people becoming obsolete? A giant electronic brain has started cogitating at the University of Pennsylvania. It's made a vacuum tube, like your radio, and it can add up a column of figures a yard long in a second. It's the world's first electronic computer. Right now, it's solving mathematical problems for the U.S. Army, but who knows, someday a machine like this may check up on your income tax.
So imagine the human abilities as kind of a landscape with some peaks, which are the things we do well, and some valleys, which are the things we do really, really badly. There are things that we do extremely well, which are things that were important in our survival for most of our evolutionary history, things like moving around and socially interacting and perceiving the world. And there are things that we have only recently learned how to do, things like general reasoning. An extreme example is arithmetic, where we are very, very, very inefficient. Computers are different. They are universal machines. With an efficient program, they can do almost any one of these tasks equally well in some abstract informational sense. So the skill of computers can be likened to a water level that's uniform. The water level is rising. And it's rising at a rate that is about 10 million times faster than the rate at which we evolved those abilities. That and a number of other calculations lead me to believe that the highest peaks will be covered by this rising flood in less than 50 years. But once the level of computer competence has risen beyond the best human engineers, then there won't be any human engineers. There will be robotic or computer engineers.